All right, so hopefully by now you've had a chance to try the review for our Unit 7 test. So this video is just going to go through some of those questions, all of those questions, in fact. Um, just give you a little more resources here. Okay, so at the top we have our explicit formulas for arithmetic and geometric, just so we don't forget. Remember, arithmetic we add every time, geometric we multiply. Okay, on to number 1. Find the next term of the sequence. So let's see. The first thing that I see is that we're alternating signs, right? Positive, negative, positive, negative. That's not going to happen with an arithmetic sequence where you're just adding or subtracting the same number every time. That will happen with geometric, though. Okay, that will happen with geometric. So that means we're multiplying by something. All right, well, how do we figure out what we're multiplying by? I'm going to take negative 18, the second term, and divide it by 6, the first term. That gives me negative 3. Okay, I'm going to take the third term, 54, and divide it by the second term, negative 18. By doing this check of, the n plus 1th term divided by the nth term, that gives us an idea of what the common ratio could be. Getting negative 3. Let's try one more. Negative 162 divided by 54. Go ahead and punch that in your calculator. I did that and I got negative 3. Okay, so that means that our common ratio must be negative 3. So to find the next term, we'll take negative 162 times negative 3. That gives us 486. Okay, we're going to write a recursive formula. Okay. So normally our recursive formula, we start with A1, and then we say the nth term is the n minus 1th term times something or plus something, etc. So if we look in our answer choices, everything is written as kind of a function format, but it works the same way. So let's see, my first term is 12. So I know that's my A1 or f of 1, if we're going by the format down here. It looks like all of those check out. Okay. Now let's see, are we adding or are we multiplying? We adding or we multiplying? Looks like I'm adding. And if I do, let's see, plus 7. Yeah, it looks like that works. Plus 7. And one thing you could do is you could just kind of check the different choices. This says plus 7. So try adding 7 each time, see if that works. This says plus 9. Try adding 9 and see if it matches. In this case, the plus 7 is what matches. So I know that it's going to be choice A. Okay, so don't get intimidated by, all of the extra notation. Okay, it's the plus 7 that matters. First 4 terms of the sequence, starting with A1 and A sub n. A sub n is 1/3 times A sub n minus 1. So this looks like this is a recursive formula. Recursive. So this is just saying, okay, I'm going to take 60, start there, multiply by 1/3 every time. Remember, multiplying by 1/3, that's the same as dividing by 3. Same as dividing by 3 every time. So we can just check, 60 divided by 3 is 20. So I can rule out that one. I can rule out C. I can rule out D. Oh, I didn't even have to go any further than the second term. Nice. That looks like that's it for the first page. Page 2. Number 4, if the pattern of blocks continues, how many will the 7th term have? So I have 1 block, 2 blocks, 1, 2, 3, 4 blocks. Okay, so are we adding or are we multiplying here? 1 plus 1 is 2. 2 plus 2 is 4. I'm not adding the same amount, right? However, 2 divided by 1 is 2. 4 divided by 2 is 2. So that says, hey, I'm multiplying here. Okay, I'm multiplying by 2 every time. So if I want to know how many the seventh term has, I could write out a formula, or I could just, start doing these terms. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2 again, 64. 1, 2, 3, 4, 5, 6, 7. So that's going to be choice D, 64. Number 5, using the recursive formula below, find the ninth term in the sequence. So we can just, honestly, 9 isn't that too high to count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're starting with 6. Okay. Looks like we're multiplying -3 times. So we're going to multiply. -18 times 3 again, 54. Times 3 again. Well, maybe this is going to be a lot because we're multiplying. It's geometric. Let's write the geometric explicit formula. See if we can save ourselves some time. So that's a sub n equals first term times r to the n minus 1. So we have first term times -3 to the n minus 1. If I want the ninth term, right? So if n equals 9, 6 times -3, n minus 1 is 8. Okay, we can punch that in our calculator if we need to. Punched it in mine earlier, and this is what I got. 39,366. Okay, number 6. The second term in a geometric sequence is 35. And the fourth term is 1,715. So this is geometric. I know I'm multiplying. So I got 35, 17, 15. Okay. For the explicit formula, I need A1 and I need R. Okay, I need A1 and I need R. I can already rule out choice A because that is the recursive formula. Okay, that's a recursive formula. However, I could say, oh, in choice A, let's see. It says A1 is 5 and the common ratio is 7. Let's see if that works. Let's check and see if that works. If we started with 5 and multiplied by 7, that would give us 135, right? Times 7 again. Let's see, 35 times 7. I got 245. Times 7 again. Oh, it gives me 1715. So, hey, that says, all right, we know our common ratio is going to be 7. And if your first term is 5, that works. So 5 times 7 to the n minus 1. And that matches up with choice B. So this was kind of an interesting problem where, just by thinking about the nature of explicit formulas versus recursive, we eliminated an answer choice, but that answer choice helped us find the correct answer. The following sequence, arithmetic, geometric, or neither. All right, well, let's see. So it's arithmetic if we're adding the same amount, geometric if we're multiplying the same amount. So 1 going to 4, so that could be plus 3, or that could be times 4, right? 4 going to 8, well, that would be plus 4, or it could be times 2. So even I'm 2 terms in, and I'm not adding or multiplying by the same amount either time. So that's going to say it can't be arithmetic or geometric. It's going to have to be neither. All right, the population of Sunnyvale is currently 4,000 people. A horrible stench develops in the sewers beneath Sunnyvale, causing half of the population to leave every week. How many people are still there after week 5? So if you're losing half every week, that's like you're dividing by 2 every week, right? And remember, dividing by 2, well, that's the same as multiplying by 1/2. Okay, that's the same as multiplying by 1/2. So I can say, all right, well, I'm starting with 4,000. So at the end of week 1, I would have half of that, or 2,000. Week 2, week 3. You see how a lot of these, they can kind of be done with brute force. You don't necessarily need to write out a formula every time. So let's cut it in half. 1,500, 250. Divided by 2 one more time, I got 125. Okay. All right, let's see. Our boy Frodo dropping a new single, straight out of Bag End. Just dropped on SoundTube. Totally real site, of course. Probably, who knows. On the first day, there were 1,200 downloads, then 1,500 downloads, and 1,800 downloads on the 3rd day. If the pattern continues, how many will Frodo have on the 40th day? So we have days, we have downloads, right? Day 1, 1,200. Day 2, 1,500. Right? So are we adding or are we multiplying every time here? Looks like we're adding 300. Okay, so I know that's going to be arithmetic. In this case, it will be useful to do a formula instead of adding 300 a bunch of times, right? So we'll do the arithmetic formula. A sub n equals first term plus common difference times n minus 1. So we have the first term, 1,200, plus the common difference, 300, times n minus 1. If we want the 40th term, well, we'll start with the 40th day. So a sub 40. minus 1. So plus 300 times 39. Let's see. Oh, it looks like I must have entered the wrong thing on quizzes. That's my bad. I'll fix that. By the time this video is out, it'll be fixed. So the answer should have been 12,900. So we're going to scratch that one out. That's what we should have put. My bad. It's Sunday. I'm tired. Oh well. So I'll fix that before I upload this video. 12,900. All right, the formula below represents an arithmetic sequence. What is the value of the first term in the sequence? So let's see. We want the first term. Well, do we even need to do anything? There's 2 things we could do. We could plug 1 in for n if we really want to do that. What's 1 minus 1? Oh, it's 0. What's 7 times 0? Oh, it's 0. Okay. Or we could just recognize the setup of this formula, a1 plus common difference times n minus 1. Hey, there's a1 right there. 28. Okay, we're using the same formula here. Same formula. I want the 12th term in the sequence. So a sub 12. So we got 28 minus what? 77. 7 times 11, 77. Let's see what that gives us. I got negative 49. Okay, which graph could represent a geometric sequence that is increasing? So you should recognize this just from the examples that we've been doing. I'm pretty sure this was a problem in your packet as well. A is linear, B is geometric, but it's decreasing. C is, oh, I'm sorry. A is linear, but arithmetic, right? C is not a sequence. That's just the graph of a line. Right? That leaves us with D. That's the shape of geometric increasing. 13, arithmetic sequence has a common difference of negative 6. So that's our D. The fifth term is 85. What is the first term? Honestly, we could just count backwards here. 1, 2, 3, 4, 5. Okay, so if your common difference is negative 6, that means you're subtracting 6, right? So if you wanted to go backwards, you would do the opposite. What's the opposite of subtracting 6? Well, that would be adding 6. So let's just start adding 6. So 85 plus 6, 91, 97, 103, plus 6 more, 109. There we go. Which is geometric. So we want to multiply by the same amount every time. Let's see. In choice A, what would you multiply? Negative 1 to negative 5? Well, you could do times 5, right? Does that get you to negative 25? Yep. Does it get you to negative 125? Yep. Oh, we didn't even have to check the other ones. You can check them. You'll see that they're not all multiplying by the same amount every time. All right, a little bit of function review. So here's a function. What is f of 3? So just plug 3 in for x. So 3 squared is 9. You could punch this in your calculator too. 5 times 3 is 15. All right, so we got 18 minus 15 plus 7. 18 minus 15 is 3 plus 7, 10. As a quickie. All right, I think we got 3 more. So which choice represents a recursive formula for the number of squares in the sequence? Well, I can rule out these first 2 choices because they're not recursive formulas. Okay, for the other 2 choices, the difference is the first term. This is a1 equals 3, a1 equals 1. Well, if I look at my design, my first term here is I have 3 squares. So it has to be choice C. All right, 17. The fourth term in an arithmetic sequence is 16, and the seventh term is 34. So 1, 2, 3, 4, 5, 6, 7. It's arithmetic, so I know I'm adding every time. Work backwards to find the value of the first term. So think about, you have to add to get to the next term. You have to add to get to the next term. Then you have to add to get to 34. So if we want to solve for D, we could set up an equation here. 16 plus 3D equals 34. You could also think about the steps you're taking to get to 34, right? It's 3 steps to get to 34. Subtract 16. Okay, so those 3 steps cover a distance of 18. If we divide by 3, give us our common difference of 6. So that says we're adding 6 every time, right? If I want to go backwards, I would then subtract 6. So minus 6 is 10, minus 6 more is 4, minus 6 more, negative 2. Okay. One more. Allie is selling flowers out of her garden. At the beginning of the day, she has 30 flowers to sell. After the first hour, she has 24 flowers. Okay, so my first term is going to be 24, not 30, because that's after the first hour. After the second hour, she has 18 flowers. How many hours will it take her to sell all of her flowers? Well, if we think, let's see, 30 to 24, that's subtracting 6. 24 to 18, that's also subtracting 6. So we could just kind of count until we run out of flowers. So 24 minus 6 is 18, 12, 6, 0. So it takes her 5 hours to run out of flowers. And that's it. That's the review. So for your test, expect something very similar to this, maybe a word problem or two added onto it. But yeah, that's it.